So in this video I'm going to show you how to, or what the solutions would be for the lesson 1415 quiz. And just to point out a couple things, the first is that as you're watching this video, you'll recognize that the order of my questions are going to be different from the order of yours. So you'll just want to be aware of that. But otherwise, I'll also have a scratch paper off here to the right, so as I'm doing my work, you can see how to get the correct answer. So for this first question here, it says Katrina stacking boxes for a giant display. In the bottom row, there are 82 boxes, and the next row is 80 boxes, and so on, with 2 less boxes on each row. Use an explicit formula to determine how many boxes would be in the 25th row. All right, so over here on the right, I'm going to write down that explicit formula, remember, is our constant difference times n minus 1 plus our first term. So for this one, we know that it's 2 less boxes on each row. So for this problem, our constant difference is going to be a -2. And we're trying to, and in this one is we're trying to figure out what the how many boxes there would be in the 25th row. So I'm going to put 25 in there for n. And we know our first row has a total of 82 boxes. So we're just going to solve this. So essentially we would just take -2 times 24 plus 82. And when you do that, you get an answer of 34. So in that 24th, or in that 25th row rather, there would be 34 boxes. Now this one says use a graphing utility to find the interval for the solution of the inequality 2x squared plus 12x plus 16 is less than or equal to 2x plus 8. So for this I'm going to need to bring up my graphing calculator. And I actually have this one all set up here. I'm just going to unselect. By the way, if you have more than one equation in your y equals section, if you hit enter, or if you go on top of the equal sign and hit enter, it'll unselect those graphs. And so I just want to graph these first two that I have up here. So I'm going to go over the equal sign, I'm going to hit enter, and now it selects those two graphs. And you can see it's selected because the black over the equal sign there. All right, so now if I go to my graphing screen, all right, so if we look back at the inequality, the first part is a parabola, the second part is a linear equation. And so when I look at my graph, I see the parabola is in blue, my linear is in red. And we're trying to find when is the parabola going to be less than or equal to the linear. And so that means when is the parabola going to be below the linear equation. And so that's going to be this section here. So when we're looking at the graph, we're looking at when is the y values below or lower than the y values for the red graph. And so again, that's going to be this section. But we define it by using the x values. So we're going to figure out when is x, for what values of x would our answers for y be less than the answers for y in the red graph. And so this value for x is at -4. This value up here, this is a value where x is -1. Now we're going to put this in, we want to put this in interval notation. Now for some of you guys, you put your answers in set builder notation, meaning you put it as using inequalities, which is fine. I went back and made corrections on that. But in the future, I'll be more clear that you want to put this in interval notations. Okay, so this would go from -4 to -1. And then we've got to figure out, is -4 and -1 included? The fact that it's less than or equal to means that it would be included. So I'm going to have a bracket here. And then we'd have -4. And then we'd have to -1. And then we'd close it off with another bracket. So that's how you write your answer for that one. Okay, looking at this next one, it says use the graph to find the solution of that inequality. So now this one we're not looking for a coordinate. Okay, so it's not asking us to solve a system of equations, so we're not looking for a coordinate. So if you said the coordinate where x is 6, y is 4, okay, that's wrong. So it's not a coordinate, it's an inequality. And so we're looking for when is this equation on the left going to be bigger than the equation on the right? Well, I got to figure out, well, which one's which. So the one on the left is in slope-intercept form. It has a y-intercept of 2 and a slope of 1/3. So that would be the red line. Okay, the blue line has a y-intercept of 8 and it goes down to over 3. So that would be the blue line. So we're trying to figure out when is the red line going to be bigger than the blue line. So again, looking at the values for y, the red line is above the blue line here at this section. And this section here starts when x is 6, and it continues to when x is infinity. So from where x is 6 going on to infinity is where that solution would be. Now we got to figure out, okay, well, which one of these bottom two is it? Is it a bracket or a parentheses there at 6? Again, going back to our inequality here, it's greater than or equal to. So that means the point where x is 6 would be included. If it just said is greater than, that means that 6 would not be included. So we would have this one here as our solution. All right, here's another graphing one. So I'm going to go back to my graphing calculator here. And again, I'm going to move my cursor over my equals here, so I unselect those two graphs. But I want to select these. Now I'll go to our graphing screen. Okay, so it says we're trying to find the values for x here. So we're going to try and find out for what values for x are these two equations equal to each other. So this is not an inequality anymore. This is an equation. So we're trying to figure out what are these intersection points. And all we care about are the x values here. So remember, to get those intersect points, if you do second and then trace, and we're going to choose number 5 here. We're going to choose the intersection. And we're going to get this little crosshair here. We can put that anywhere on one side of the intersection point, so I'll just leave it there. I'll hit enter, and now it puts another crosshair on the other graph, so I'm going to put it on the other side of the intersection point and hit enter. And remember, this changes to guess. We hit enter one more time, and now it says intersection. So at that point, the x value is negative 1.4. Now again, we don't care about the y value, all we care about the x value. So, but we do have another intersection point, so to get that other intersection point, we have to go through that process again. So I'm going to do second, and then trace, and select intersect, option 5. Move this cursor. We don't have to move it right on top of the intersection, as long as it's somewhere close there. Hit enter, and then we're going to put this crosshair on the other side of the intersection. Hit enter twice. And we get now that that intersection now is at x, where x is 3.4. And again, it doesn't matter what order you would put those in. If you would have put the 3.4 and negative 1.4 second, you would have still gotten full credit. All right, on this one. So this one I gave you the graph. We're trying to figure out the x values where these two graphs intersect. And so this x value is where x is 3. So we would select that. And remember, it says select all that are correct. So we could have more than one correct answer. So where x is 3 and where x is 6. And so we would select those two as the correct answers. This one I think everybody got correct, if I remember correctly, but we want to find the next 3 terms of this arithmetic sequence. So we want to look at the pattern here. So it goes from negative 15 to negative 8, and from negative 8 to negative 1. And so we want to figure out what the constant difference, what are they adding each time? And if you're not sure, you just take on your calculator, take negative 8 minus negative 15. So it would become the same as negative 8 plus 15. Or negative 1 minus negative 8 would become negative 1 plus 8. In either case, you get 7 as your answer. So we're adding 7 each time. And so if I take negative 1 plus 7, I would get 6. And then if I take 6 plus 7, I would get 13. And if I take 13 plus 7, I would get 20. So those would be the next 3 terms of that sequence. All right, so this one is all about knowing how to read sigma notation. So if you got this one wrong, you want to make sure you understand what sigma represents. Sigma represents that we're adding a bunch of numbers. And underneath here, it tells you what term we're starting out with. So we're going to start with the first term. And up here, it tells us how many terms total we're going to deal with. So this would be a total of 20 terms. So now we use this over here on the right. That's an explicit formula to find out what the value of those terms would be. So when it says how many terms there are in the series, we would say that there are 20 terms in the series. When it says what is the first term in the series, well, that I'm going to go back over here. I'm going to, let's see, do this. Let's get rid of all that. All right. So to figure out what is the first term in the series, that's where we're going to use that explicit formula, 3 times n plus 4. And so to find the first term in the series, we just put 1 in there for n. So 3 times 1 is 3, and then 3 plus 4 is 7. So the first term in the series would be 7. When it says what is the last term of the series, we're going to do that same formula. This time, though, like we said, that 20 is the last term, so we want to figure out the value of that last term. So we take 3 times 20, which is 60, plus 4 is 64. So what is the sum of the series? For the sum of the series, remember we use this formula, where we would have the number of terms times your first term plus your last term, all divided by 2. So for this situation, we know that there's 20 terms in the series, so technically you'd have 20 under there, not a big deal though. But we'd have 20 times our first term, which we found to be 7, plus our last term, which we found to be 64, and all that divided by 2. So that you would just plug in your calculator. Now if I were to plug this in my calculator, I would do this in 2 steps. So I would do the numerator first, and then divide by 2. So when you do that, you get 1,420 in the numerator, and then we'd have divided by 2. And when you divide by 2, you get 710. So 710 would be the sum of that series. So you want to make sure you know how to read sigma notation and how to use that explicit formula to find the values of each of those different terms, so you can find the sum of a series. So if I were you, if I struggled on that one, you want to make sure that you have that sum of a series formula on your cheat sheet. Remember, you can use all of your notes, but I would recommend using a cheat sheet on the test, so then that way you can just have a lot of the key information all in one spot. All right, so this one here, we're going to use that same formula that we just talked about. So it says to find the sum of the series with 36 terms, whose first term is 2 and last term is 48. So we don't have to find anything specifically. We're just going to take, well, the first, or the number of the terms in the series is 36. And we'd have the first term is 2, and our last term is 48. And we divide by 2. So when you do that with the numerator, you get 1,800. Divide that by 2, and we get 900. So the sum of that series would be 900. So for this one, this is a recursive formula. So we know the first term here is -8. And then this bottom part down here is telling us what to do to find the next terms of the series. So it's either going to be the second or the third one here. But we're subtracting 3, -8 to -11 and -14. So that would be our answer. For some reason, it's not letting me select that. There we go. But yeah, so it'd be that one would be our problem. All right, so let's look at this last question now. So this last question, it gives us the sequence, and we need to find the explicit formula, and you want to make sure that you do that in simplified form. So please make sure that when you're taking these, make sure you're reading the instructions very carefully. So we're going to type this in and make sure our answer is in simplified form, and there are no spaces. Okay, so I need to figure out some details here, because remember, again, this is another formula that you could have on your cheat sheet. That'll make it a lot easier, like I said, when you're taking the test, to just look at and quickly find the formulas that you need. And I would describe it. I wouldn't just write this down. I would make sure I write down maybe why I would use this, or use this for explicit formula. So in that way, you just have a note to yourself as far as when you would use that formula. All right, so we need to figure out first off, what's our constant difference? So I see we're going from -3 to 5, from 5 to 13, from 13 to 21. So we're adding 8 each time. So our constant difference is 8. And the n is going to stay a variable, so that's not going to change. And we can see that our first term is -3. So I'm just going to plug what I know in here. So we'd have a sub n equals, and then we'd have our constant difference, which is 8 times n minus 1, plus our first term, which would be -3. So now when I simplify this, we would distribute the 8 through, so we'd have 8n minus 8, and then plus -3. And -8 plus -3 would be -11, so we'd have 8n minus 11. Now, I apologize. This is the explicit formula. I forgot, when I was typing in this question, to have a sub n equals as part of the question there. So some of you guys wrote down answers like this: 8an equals 8n minus 11, and it didn't fit. Okay, so then hopefully, because a lot of people then recognize that, well, if I just do 8n minus 11, now it does fit. So if you didn't make that, I tried to catch all that, so if you didn't have that, or if you lost a point because you had 8n, a sub n equals 8n, and you ran out of space, you just left it like that, let me know, shoot me an email, and I will give you credit for that. But otherwise, I'm pretty sure I went through and caught anybody that made that mistake, or it was more my mistake. So anyways, on the test though, the a sub n equals will be part of that, and you just have to figure out what is the actual explicit formula that we'd use to get the different values in the sequence. So hopefully that makes more sense. All right, so that is the quiz, and I know, like I said, some of you guys had some questions on that, so I'm hoping that this does answer the questions you may have had. If you do have other questions, though, please make sure you ask me, and I will do my best to get back to you on those.